Good morning. Today is the 29th of November, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day. Sometimes I stream it here on Twitch. So the stream today, I think I'm going to be doing two parts. I have to, hey, White Comp Phil. So I'll probably do 5 to 7, 7:15 here. And then I'll be out for about an hour, and then I'm gonna come back and do a second part. Hey, Bumblebite. Welcome. So, yesterday, I did fix some of the bugs that were left in the parser, but the big one is still outstanding, hence why we're on part 13 here. But I think I have a solution. I think we can get through it fairly quickly, I hope. We'll see though. So the first one was related to the with prefix parser, so the with expression. So if I bring up that test file here, here's the scenario that I had to fix. The being able to do this like with X, right? So X is 1, 1 has a field A that is a 2, 2 has a field B that is a 3, and 3 has a C, which is a string. But to be able to say with dot A, with dot B, with dot C, the parser needs to translate these at parse time into binary operator nodes that are member access, right? Because we know what the context of this is, it's X. And we know what the context of this is, it's X dot A. And we know what the context of this is, it's X dot A dot B. So we need to kind of help the compiler along a little bit and do that up front. Sorry. So it was fairly straightforward. I refactored this. We grab the current width. We parse the left-hand side if it is a member with or a with member access. So in other words, if it's a dot and then some identifier, and we're in the context of a with expression already, then we just, the left-hand side of the new with node that we're generating, say that like 10 times super fast, the left-hand side becomes the left-hand side of whatever the current with context is, a dot operator, and then what we just parsed, the right-hand side of that. So what ends up happening, like I say, is that this then becomes X dot A, X dot A dot B, X dot A dot B dot C, right? Behind the scenes. So again, the with construct is very much a good example of syntactic sugar. It's just shortcutting things. This solves the problem, but it introduced a new problem. So, as always, right? Always got to be something new. And I think I had run across this before, and I thought I had fixed it, but I didn't realize exactly what the problem was at the time. So now I have a much better understanding. So the issue is Okay, so first, the compiler is completely fine with me doing this. Right, so as far as the definition of the types is concerned, the compiler supports any ordering here, right? So even though 2 is not defined yet, it will get resolved later and 1 will be fine, okay? So insofar as the struct definitions are concerned, this works and this works. However, the binary operator, the member access binary operator, the way I wrote it, is flawed. So the issue, and I put a note here and I put a note actually in the AST evaluator. And essentially the issue is when we come into the binary operator evaluator, if it is a we check to see if it's a composite type, and if it is, that gives us a hint about whether or not we can do a member access. The problem is this is happening before we get to the end where we do all the type fix up. So in the case where the ordering is, things are not predefined, these end up being unknown types, and that doesn't work. This code fails. But if you predefine the types, then this code succeeds. So the issue here then is this needs to be rewritten such that if it's an unknown type and it's a member access, then it goes into some kind of deferment list, right? And then as part of the type resolution, when that happens, this gets processed as well, right? So in other words, we say, oh, hey, was this identifier an identifier that was used in a member access? Oh yeah, it was. Okay, now go back and do this. Verify that, in fact, they did use the right fields for that type, and instead of it having to be in line here. So if the type is defined at this point, then we would just execute the code more or less as it is here. However, if not, we'll put something in some collection and then we'll process it at the end. That's a minor issue, right? It's a bug, but it's not really related to the parser. It's more related to the compiler. But I made notes about it. And again, as long as things are predefined, then when we get down here, the translator is able to do these at the point of translation, and it works the way it's supposed to work. So I fixed that. So that was good. So let's talk about yesterday. Was it race? Bonjour, Alex. Enchanté. Okay, so commas. Commas in Basecode are a bit different than like C or C++, because like I said yesterday, I support things like FE equal EF, right? So the assignment operator has to be a higher priority, higher precedence than the comma. However, when we get inside of procedure calls, then the comma has to have a slightly different or we would like the assignment operator to have a different precedence to the comma. However, the way I did this, which kind of solves like 70% of it, but it's not a good idea. I changed the precedence. I'm gonna back all that out this morning, because what happens is when you change the precedence, then this construct does not get parsed properly. It doesn't get parsed as an entire thing. It sees a comma here, a comma here, a comma here, a comma here, and it gets turned into this ugly set of nothing, right? It's meaningless. So that's a problem. Now, if we fix that, which we can do very easily, it will break. So if we take a look at struct literal, it will break this sort of thing. However, I think I have an idea of how to do this without introducing new syntax, and the level of complexity increase in the lexer is modest. It's minor, in my opinion. Now, it does make the parser context dependent, but the parser is already more or less context dependent, so I'm not too scared by that. So the solution I have in mind is the lexer will have a counter, essentially, that every time we hit an opening parenthesis, it will increase that counter. Every time we hit a closing parenthesis, it will decrease that counter. And then the lexer function for the assignment operator will check that context. It will say, am I within a parenthesed expression? If I am, then the assignment operator will be given a different token type. So instead of, I'm thinking this will just be called the key value operator in that context, right? And so then that becomes a completely new infix token. So the precedence of this infix token can be different from the assignment token. And so then we can use the same syntax, which I personally think is natural. It makes it easier. The language is consistent at that point. But internally, we can treat them separately and parse them in different ways. So that's the plan. So the first step on that journey here is we got to back out the garbage I put in here. So first, assignment has a higher precedence than comma. That's the default. That's what we want. Because if we look, use global, what this does is this makes the comma, temporarily gives the comma parser the precedence of the assignment and the assignment vice versa. So yeah, we're gonna kill these. Don't need them. It was a bad idea. I'm chock full of them. Lots and lots of bad ideas. I may have to look back in history here. I'm not sure if where are we at? We're in comma infix. So what did I? Boy, I made that change farther back than I expected. Okay, yeah, so I was doing what I'm doing now. I just want to make sure I was in fact actually passing the precedence in that case, and I was, so that's good. Okay. Yeah, the thing is though, the key value pair is going to be, it's used everywhere, right? It's not just maps constructor, it's maps, it's in procedure calls for name parameters, it's everywhere. So I really need a generic syntactical solution for it, and I don't want to have to force people to create tuples to express that. And I debated, I mean, I could solve this problem by coming up with some other syntax, right? But I don't know, the more I thought about having to create new syntax for this, I just thought, man, I really don't. And maybe I'm going to look back on it in 2 months and be like, okay, when I rewrite it in Basecode, I won't be so picky. But yeah, right now, I'm just thinking I would rather have the same syntax there. But it's also good too, in a convoluted way, I guess, because it forces me to think about, okay, down the road here soon, I have to really start thinking about what model I'm going to use for the language generation facilities within Basecode. That's not something we're doing in the Bootstrap compiler. We'll do that as we're rewriting the compiler, but I need to consider like how a context-dependent grammar would be handled. So it's a good thought exercise. so we're going to use the arrays file as our test, because that was failing. My guess here is that it should be fine now. Of course, we broke other scenarios, but we're going to come back down and fix that. Okay, yeah, it's fixed now. So taking out that stuff, this now parses and translates properly. This is being treated as a whole expression, and so we have an array, it has an array. So, but what's not going to work is let's do struct literal. This one is not gonna, I expect it to fail because there are assignment operators right now inside of a comma separated list, and yeah, this fails now. And it's failing exactly where I expected it to fail. Okay, so that's all good. So the next step then is in the lexer, and we're going to do unit 32 and have a paren depth, and he starts off life as 0. I'm going to do left paren increased paren depth. So if paren depth is greater than 0, we decrement it on a close. So now this does include, like, if you had parenthesis grouping around expressions on the right-hand side, right? This would include that as well. That's okay. I think in that case, you're not most likely doing assignments there. So I'm okay saying, hey, look, if you need to do an assignment in that case, you just can't be in parentheses. But yeah, I'm having a hard time imagining what that would even, any scenario where that would even be used. So I think this is safe, kind of a categorization. And this is a very lightweight burden, right, on the lexer. The lexer already is dealing with the fact that we're keeping count of how many, that we're within the context of a parenthesis grouping, I think is pretty minor. So then we can come here to assignment. And actually, before we change this, we need to add a new token type. I have, so I'm just going to do key value operator. Hey, Romania hate. Okay, so it has the same value, but it's a different token. Okay, I'm back. Yeah. So the token we return if the paren depth is 0, meaning we're not inside of a parentheses thing. It's just the regular assignment literal. Otherwise, we return back the key value operator token. That's it. So first, we'll rerun it on the, well, I should have run it on the array thing first, but we'll run it on the struct literal test file. What I expect to see now is that the parser is going to error saying that it doesn't have a prefix parser, or I'm sorry, it doesn't have an infix parser for, well, one of them, for that token, right? That key value operator token inside of the constructor functions. Which that should be easy to fix. Because we have a new token type, we'll have a new parser, infix parser for it, and we can define a distinct precedence for that one operator, and that will have a lower precedence than the comma. And so then the comma will consume that the way we expect. So the assignment operator breaks comma lists apart, which is what we want. The key value operator is a lower precedence than the comma and is consumed by the comma. Excuse me. Okay. Yep. But found key value operator. Good. All right, so we're getting the right, these are being treated as assignments. This is a key value operator. All right, so now let's go to the parser and let's go to here. This will be key value infix parser. And then in precedence, value. Okay, so assignment is higher precedence than comma, key value, and everything else is lower. So that is perfect. Oh, and actually, Okay, so then in our infix map, so we added the new infix parser for that token. And okay, so I can I could continue to use the assignment node for this, because at this point what we're generating is going to the compiler, and the compiler currently is designed around assignments in these places. I could do that, and I'm kind of tempted, at least temporarily, to do that, because then it doesn't break anything downstream. But then on the flip side of it, if I created a unique AST type for it, then it does give us that slight extra bit of capability then to distinguish it. And I think right now there's only 2 spots. Well, and when I think of that, it's really only one that's gonna break, and that's procedure expressions or procedure expressions, and no, just procedure expressions actually. So, because we haven't really plumbed through name parameters in procedure calls yet, so it doesn't really matter what type. And honestly, yeah, again, I think the impact in AST Evaluator is pretty minimal. Okay, so for composite type fields, but this is okay. This is going to stay the same. That doesn't change. This is for creating new identifiers. This doesn't change. Argument list. Okay, so this would change. So if we add a new AST type, this would just swap. Right? So instead of being an assignment here, we'd be looking for a key value here. And whatever we create, it's the same. This I think is, this is procedure expression. So this would change. Except I am using add assignments to scope here. And that's, I think, too little. Yeah, so this would change. I think I'm gonna, I don't know, I think I'm gonna leave it for now. That's a less pressing issue. That's it. that's not causing problems ultimately. And we could, trying to think if there's a way I could annotate this to be like, hey, it's a key value assignment. This is a parser for a programming language I'm designing called Basecode. So I'm going to leave it like this for now. So we're going to test this with the struct literal test file. And if my idea is correct, crossing my fingers, this should parse and code generate, well, to the extent that it does at the moment. But it should fix the comma issue. And then we'll test the array one. Then we'll run the test file, run through all the tests. And then only one should fail right now. And that's the one with the composite type stuff that I haven't done anything with yet. Booyah. All right, so that one works, and arrays should work too. Then we'll test all of them, and I expect only one of them to fail. Beautiful. Yep, that's a beautiful site. So the one file that we have, which is composite operators, yeah, this is fine, right? But arguably, yeah, this, I'm going to leave this test in here even though it's failing. I mean, I know what it is that's failing, so I'm okay with that. So that fixed that issue. And I'm much happier with that solution than what I had before, and the idea that I would have to introduce additional syntax. I was really trying to avoid that. So this now parses properly again. And what did I do? So I introduced a new token type called key value operator, added that to the name map, and then I also added a static token for that particular operator. It's the same, it looks the same as assignment, but it's context dependent. the way that we're disambiguating this now is in Lexer, I keep track of the parenthesis depth. So we can't just use a Boolean here, right? Because if you just use a Boolean, yeah, you can get the leading edge correct, but as soon as you get a closing parenthesis, you don't know if they're paired, right? So you have to do a count that works. So every time you see an open, it increases. Every time we see a close, it decreases. So then inside of the Lexer, here's an example for the left paren, we increase the depth. And then for the closed paren, we check. We don't want to, because this is a unsigned integer, we don't want it to overflow. So we don't want it to wrap. So as long as it's greater than 0, we subtract 1 from it. And then in the assignment, right, so we match that token, but what kind of token it is, or I should say we match that literal, what kind of token it is depends on what context we're in. So if we're within a parentheses expression, then it's a key value operator. Otherwise, it's an assignment. And so now the Lexer is emitting different token types, which allows the parsing infrastructure to go down different paths. Also, because we have different token types now for assignment and key value, they can have different precedences that are fixed. So assignment, comma, key value. And that's the fixed precedence ladder that we want. So then I added a new key value infix parser, and I got rid of a bunch of code I had added to do this kind of dynamic precedence changing, which was, in hindsight, a stupid idea. So I took all that out. Yeah, so that came out. These came out because these were doing the swapping, don't need it anymore. Then I added an instance of the key value infix parser and then put it in the map for the key value operator. And so then in the implementation file, the precedences are now fixed again. So for assignments, we don't have a method we call to determine what the precedence is. We just use the actual precedence. I added the key value infix parser, which is mostly doing the exact same thing as create assignment. However, I copied that code because A, I needed to change some text in the error message, but also B, the precedence is different, and C, if I decide I want to start customizing this down the road, I want it to be separate so that I can customize it if I need to. But for all intents and purposes, this parser is doing the same thing that the assignment parser is doing, just at a different precedence level. And then for the comma parser, hard-coded the precedence, and same thing for the assignment infix, because those aren't variable any longer. Got rid of this stuff. These were methods I was using to dynamically change the precedence on these parsers. Again, bad idea. So, yeah. And that's it. And then in the arrays test file, I got rid of the comma or the comment describing the problem, okay? Because we don't have that problem any longer. And yeah. Ironically, so this is a compiler thing, or I should say this issue that I'm about to describe, this is on the compiler side of the infrastructure, not the parser. So I'm not considering this an issue with the parser, but technically, right, this is incorrect because this would be an error, right? So this could be an array of any, and then this would be correct. So there's type checking here that's not on the compiler side, that's not right. But okay, so technically that should be an array of any, and then this is valid. So actually, let's just test that, make sure that's okay. It should be. Check it in, and then that's it. That's the last known bug that I have with the parser. I'm sure there are lots of other little bugs. And the more that I actually start writing Basecode source and, you know, doing more typical things that you would do with a language, I'm sure I'll run into them. But at this point, I think most of them are minor things. Yeah. All right, we're good. Yay. Oh, so before we commit, let's just double check our to-do. This is fixed. Yeah, these are fine. These are still, and these are all compiler side things, so. All right, that is done. Okay, so now I actually got that done pretty quickly. It's under an hour that it took me to fix that. I kind of expected it to take the full 2 hours. But that's okay. We can actually, I can make plans for when I come back here. All right, so let's go through these. Stack frame displays. It's a weird word. I'm not really sure why they called them display lists. I'd have to read documentation from the year again to understand why they did that. But what this really, stack frame displays, what this means is, so when you have static context, I think I might have one. Scopes, or does it stack? I can't remember what I call it. Stack frames. I think this gives a, yeah, this gives a pretty good example. Okay, so this procedure, okay, is static to this procedure. This procedure is static to this procedure. What does that mean? What that means is that you can't, like I can't invoke nested one from outside of simple. Simple is, nested one is local to simple, nested two is local to nested one. But nested two has visibility to the scope of nested one and simple and bar and test namespace foo and global, right? So the idea, there's a couple different ways that compilers do this, but one way is what are known as displays, which are just pointers. And because the compiler knows that this has 1, 2, 3, 4, 5 parents, right? When this code is generated, we end up with a stack frame that has 5 display pointers in it. And that's why they're called display lists. And what that does is that then allows us to straightforwardly access anything in the parent scopes. And we know, like, if nested2 is invoked somewhere within simple, or actually, yeah, let me restate that. If nested2 is invoked somewhere within nested1, we know that nested1 is active. We know that simple's active. Now, what we don't know, or what I need to kind of decide how I want to do this, is we don't necessarily know that bar is active here, or that this namespace is active. So, like, what namespaces are and where those things get stored, if that's on the stack, or if that's module level, or what you would call global in C or C++. I haven't quite made up my mind on that yet. But that's what this particular card is talking about, is how's that going to work, right? And this is a bit different than closures because it's not dynamic. But it you can access I here, right? For most uses, it's going to be very similar in concept. But there are limits there. It's not actually a dynamic closure. So what do I mean by that? Again, let's say somehow I could escape a pointer or a reference of some kind to nested2, and we can call it outside of the scope of simple. This does not close over anything. Like, this only is intended to function within the context of these being active. As where closures, right, they can escape, they can go somewhere else and come back, and they close over the context in which they operate. Now, you can run into problems with, like, lambdas in C++, right, because they're only pseudo closures. They're not complete closures. So you can run into kind of some of the issues that I'm describing here. Like, again, if somehow nested2, I could make it visible for that to be called outside of the activation of these, then yeah, bad things would happen, right? Like, this is going to refer to something else on the stack at that point, not what it thinks it's referring to. So so yeah, so that's that one. So I think this card yeah, so this card here is really kind of, this is more like a footnote on this card, right? We need to support static displays of some kind. That's just part of doing the stack frames properly. So that's one part there. Hey, Synox. Should numeric literals implicitly type convert? So, gosh, this one's old. I'm trying to remember where I even... Was it compiler variables? No. Short, I think it was short. Yeah. I think if I remember correctly, like this was an example of 68, right? E is an F64. If I multiply it with a 3, right, without the cast, this is a U8, because that's what it fits into. Now there's another card. Let's see if I can find that. I'm pretty sure it's in here. Maybe. Nope. Oh, nope, here it is. Although it's kind of oddly named. I went right by it. Here, yeah, so actually it's kind of the same. It's binary operators should automatically widen literals. So again, like there's this, there's the letter of the specification, right? Letter of the law and spirit of the law. So the letter of the law here says this would be an unsigned byte because that's what it fits into. But in the spirit of interpreting that law and pragmatism, does it make sense to always narrow these down to the actual smallest that they can be? So typically, right, like a lot of languages have their default integer type, and which is not usually the smallest, right? It's usually whatever the word size is on a particular architecture. So 32-bit or 64-bit, whatever, probably 32-bit, we was okay, this is actually a U32 here. But that doesn't really change anything as far as the first card, because the compiler's still going to say, hey, you're trying to multiply an F64 by a U32, and I don't like that. So what are the pros and cons? So the reason I do not want to implicitly type convert these is because then when you read the code, you have to do the conversion in your head. You have to know that 3 is going to be some kind of integer type and that the compiler is going to coax it to an equivalent float type so that this binary expression will function properly. Likewise with the remainder of this. So and then the problem with the implicit conversion is which wins, right? Is it the intention that you wanted to multiply floats, or was it the intention you actually wanted to truncate and multiply a float to an integer? It's not clear, right? So I'm really thinking right now that I'm not in favor of implicitly type converting numeric literals here. I'm thinking that you have to cast them. What I don't remember is why I had to cast, like I get that I had to cast this because it's an integer. Not sure why I had to cast that. Because to me, that's already a floating point. So the other thing is, okay, you could say that types cannot convert, an integer can't become a float can't become an integer, whether it's a double or a float. A floating point cannot become an integer can't become a floating point. Yeah, I thought, okay, so I'm not sure why I was explicit with that, because I figured that would work. So okay, that works the way I expect then. Because let's see, point. Okay, here's the cast. That's this right here. And then right, cast F64 from U8, add, so these are 32-bit float, right? So that's the other question then, like the constants, and there's actually a comment in the code, I think, for, is it new in numeric type? Yeah. I think there's a comment in here that, no, actually this one looks okay. So narrow to value here, it's literally, it's looking at the value and saying, okay, which range does it fall into? Maybe, I think it's integer, no? I thought I had a comment somewhere where the narrowing code there wasn't what I wanted, but what's happening is these are, again, the same thing. This is a byte, it fits. This is a 32-bit float. It doesn't need to be a 64-bit float. You can turn it into one if you want. So that's why, I think that's why I was casting it, is because I wanted to force it. But the code that it's generating looks fine to me. Because once you get here, this is always 64-bit. This is not doing, it's internally it's converting so it can do the math. Okay, so yeah, I'm gonna say that, because the other thing, and C and C++ do this, like, this is kind of similar to what I was talking about with the type narrowing here. It will widen, right, types automatically. So that's the other thing too, like, okay, so this is a float, but obviously this side of the binary expression here is an F64. So then do we widen automatically? And I don't like that either, to be honest. I would, if I decided to actually just make this an error and say, well, I really don't want you to mix F32 and F64, then you would just have to cast it. Or you could make a constant of it, right? So that you don't have to cast it all the time. But because what happens, where that starts to get interesting, especially when we get into like type polymorphic functions or generic functions, right, where you have type parameters. If the compiler is arbitrarily widening things or changing types, then that stuff may not work the way you expect. And I would rather not introduce too much ambiguity there. At least that's my current thinking on it. So, with that ramble out of the way, I think the answer here is right now, no. All right, so that one's done. We're not going to do anything with that. And then that comes to the next one, right? Should the binary operator widen things? And I think the answer here also is no. Oops. And like I said, maybe I'll come back, we'll get down the road and I'll start writing a bunch of code. But again, I think the way around this is, like if you have magic numbers, you could just create typed constants for these and then you don't have that issue anymore. So, yeah. Okay, so we talked about the stack frame displays a little bit. We haven't talked about stack framing and scoping in general. I'm going to come back to that. Obviously, we need to get to the native code generation. All statements are expressions. I mean, I think we're kind of at that. The plumbing is there to support this. But I probably should create a test case to make sure that it, again, at least structurally, all the parts are working. And what those tests would just look like is if you had an if statement, right, you can assign the result of some if ladder, or a switch, you can assign the result of some switch to something. These are going to be the instruction flow barrier stuff. This is going to be meta instructions in the bytecode stream. And this is actually kind of important because this is going to help us flesh out, and I actually might break this up in a couple things. This is going to help us flesh out the meta instruction stream for like debugging and all that as well. I have some initializer, finalizer stuff happening, but it's pretty hanky at the moment, pretty janky. Needs to be really. So this, generate fully qualified label names. This one's almost like gotta be one of the first ones we do. So what is that? We look at the assembly output here. So the type stuff is okay, right? Because this is emitted by the compiler up front, and these are unique. So all the intern strings, but as an example, inclusive. Okay, so where is that coming from? That's coming from the support module, right? That's this. The problem is the label needs to be unambiguous. And right now, Like, so if you had two modules that had inclusive defined, it would blow up because we'd end up with multiple labels in here with the same name. So this also, it shouldn't be case preserving here. This needs to go to lowercase, but this should be something like the module ID. So be like underscore module yada yada underscore namespace ID underscore, you know, so that it's completely, the labels are truly unique. And that goes for all of the labels that get used right now. I mean, initializer, this again is kind of like a top level label, so that can stay, because this is where we actually jump to at the very top. But 99% of the labels need to be generating uniquely qualified names. And they're not right now. Now, some of these, like binary operator labels and stuff, these are okay because these use the ID. I do want to make them shorter though, so I want to change this to like bin op, so they're not quite so long. But that's, that card, that's what that's referring to, is all the labels, because we're taking all these modules, right, and we're pulling them in, and they're turning into a flat assembly listing with a flat namespace, right? The assembler does not understand anything besides just the label, so the labels have to be unique. So that is, yeah. That's that. And then there's some other issues around the naming of some types, the name that gets generated, especially for like arrays and pointers and stuff. So I think kind of packaged with this, I'd want to go through and test and fix that stuff as well to ensure that it's coming out properly. Defer, this is going to have to be really, yeah, this is kind of sort of tied. Yet again, this is where I wish in this card interface that I could link cards together, because like this really just needs to be underneath that, and this needs to be underneath that, because defer is tied to the scope that it lives within. And there's not really anything, like defer itself is really just a signal to the compiler. But I think what I need to do is in scope, I think we need to add a stack of pointers to defer elements, right? So within a block, if you have defers, as those are added, right? So you have the statements as they appear in source, but also we would have this stack of pointers on the block that tells us what the order of those are, because we want to push those on the stack because they want to operate in reverse order. And when we do code gen, right, we're going to skip over defer statements. We're not going to emit those as they appear in sequence in the block. Instead, we're going to wait until the end of the block. Then we're going to look at that defer stack and we're going to emit them at that point. So that's really, I think, the only unique aspect of defer. And that's actually fairly easy. What I just described, I mean, everything that we need is there. So that's something we can do pretty much, I think, right away to make that work. because defer itself just passes on to whatever it has, right? So if it has a statement, one expression, or it has a block or whatever, it just, whatever that code is, it gets emitted. Again, the only thing special about defer is just that unique signaling to the compiler that they need to be emitted in a certain kind of order. So procedures with return types require a return statement or expression. This is, so this is really here when we're doing the, this is in the AST evaluator. We need to look, okay, hey, which we already do. Is there a return type? Yes, there is. Okay, is it a tuple? If it's a tuple and it's got named fields, are those referenced anywhere in the body? You know, so there's like a whole list of things that we have to do to make this work right. But this is really just a validation, right? Are you returning something when you should be? Yeah. These are just like placeholders around a whole bunch of functionality, right? So these I think I need to split. So let's do this. Since we're done with the parser, let's rename that to task to break down. We need to break this down into, like, I know, for example, enum is not doing the automatic numbering and typing and, you know, it's string. That's kind of related to, you know, finalizers, initializers, and finalizers. These all kind of need to be broken down into smaller chunks that are actionable. So this one's really actually pretty important. Implement unfold. I got a lot of the plumbing in place and I did some very simplistic things with it. But this is kind of holding up a whole bunch of things. So let's see, do I have an example? Maybe. Well, we'll use this one. Okay, so if I make a variable here, 2 times 2 plus 6, okay? This is a constant expression. This can be folded by the compiler. I don't need that anymore. But onfold doesn't do anything for that yet. So what that means is that J is initialized. I mean, J is created in memory where it should be, but it's 0. And then by id, literally by id. Yeah, so J is 0, but it shouldn't be, right? So this should be 10, and it should be initialized to 10. The reason it's not, again, is because I don't have any compile time evaluation of this. I have the parts sort of in place, but not implemented. So this is actually pretty critical because these kinds of things we need to start getting, because otherwise, you know, I'll start writing code and that's not going to work. And it should. So that's what that is. And that is actually a prerequisite to this static if, else directives, right? In order for these to work properly, we need to be able to take the expression that, right, we need to be able to say pound if foobar is greater than 2 or whatever, right? Whatever expression we want. And this needs to be able to fold to a true or false. Again, I think all the plumbing is in place. The evaluation's just not, right? Like in binary, almost all this is in binary operator. Binary operator fold just needs to be implemented so that this works. And obviously if foobar is not a constant value, then, and this is not a constant value, this is an error because this is a compile time thing. But same thing with compile time assert, right? This requires that same functionality. So that's actually pretty critical. If anybody from GitHub's listening, please make a feature where I can just like drag a card underneath another card and they relate to each other. That would be so cool. And then like have it indent a little bit. So and then I kind of just hand wave past the code generation, but again, for the code generation, I originally was thinking about using a semjit. I might still do that for the bootstrap compiler, because really for the bootstrap compiler, the only thing I need to absolutely target is x86-64. I don't really need to target anything else. When I rewrite the compiler though, I'm gonna have to probably build my own code generator or do what everybody automatically expects that you would do and just use something like LVM, although I'm not, I don't know, I'm not a huge fan of that idea, but yeah. Because semjit, they have a very prototype ARM code generator in there, but it's, I don't know how far out it is from being usable. I think quite a long way. So how else can you get decent debugging? So there's actually, as far as debugging is concerned, there's going to be 2 levels of debugging with Basecode. So first off, I intend to actually build my own debugger for the interpreter. And at least my initial target there will be to make it compatible with something like GDB or whatever, so that it can plug into something like CLion or anything that supports that. And I just, on the really high level review of what that looks like, I think that's doable. I mean, worst case scenario for the interpreter, I can literally just build my own tool using Qt or something, and have it integrate with the interpreter directly in some fashion, using 0MQ or I don't know, memory or whatever. I could come up with a mechanism to do that. I would rather not do that if I can find a more generic way, but I definitely want to be able to debug the interpreter at the interpreter level, especially when you start doing meta programming. I think that's going to be really critical. Plus, in the bytecode stream, I'm going to have these meta instructions that have arbitrary specialized data in them, right, that other debuggers will not be able to interpret immediately. And again, once we start getting into meta programming, I'm seeing those as being important. Now, the native code stuff, the debug database formats that are out there, like PDB and whatever, those are well defined. So as far as native code generation, I mean, that's just another format that just needs to be generated so that you have a debug symbol database that goes with your native code. So I'm not other than the effort of, yes, having to generate that file output, I'm not seeing that as a huge stumbling block. I mean, obviously, again, something like LLVM it does that, but there's quite a bit of overhead to it to make that work. So, yeah, I don't know. I haven't gotten to that point yet, but that's definitely something I'm weighing. So of course, what's missing here is, all the code gen for all the constructs that we don't have in here. The other thing that's missing is we need some code flow analysis and again, CFA is kind of related to all the scoping stuff. We need to do code emit for all the elements. So I'm sure there's other things, but let's take a gander here at program. Oh yeah, so we got to do type literal data emit. Oh yeah, we need some kind of a type cache. Because there's places where I'm looking up types because I know I'm going to use them a lot, but I should, as part of Scope Manager, right, there should be a better caching mechanism there. So I gotta rework that. Yeah, we gotta. So right now, assignment is not doing a copy if it's a composite type. So if we go back to this, if I create a string and I assign B to that string, right? This should be there's a instruction in the interpreter called copy. This should be a copy, not whatever the address of this is. This should be that address. We should load the address of this, load the address of this, copy the size, the bytes from this to that, right? That's what should be happening. And I'm almost positive right now that's not happening. It's just assigning the address of A to B, which is creating an alias, which it shouldn't be. Yeah, see, we're loading A, or loading B, loading A, and we're loading the value of A and we're putting it back in B, which is that's not what we want to do. This should be a copy, right? In this case, which is, I think that's easy to fix. We have all the parts. I just need to put the little block of code in there so that it recognizes that this should be a copy, not an assign. And the good news is, once that's in place for any composite type. Now there's a couple special cases, right? We don't want to do that for pointers and things, but because those are internally composite types too. But I think is pointer a composite type? Or did I make that standalone? No, it's standalone. Never mind. So. But obviously, this is a copy in the sense of like how C would work. So internally, string has a field on it, data, which is an allocated block. So this is a copy of the fields of the structure. So B has, in memory, there's a block for B, there's a block for A. B has a length, B has a capacity, B has a pointer to a block of memory. Those fields are copied, but B and A both alias the same location in memory in terms of the actual data underlying the string. Now, one of the things that I eventually want to do is, and I think I talked about this in the composite operators example. Yeah, so the idea here is at some point you'll be able to specify a user function, user procedure that the compiler will see, because the compiler will look for these attributes that tell it, hey, this particular procedure implements an assignment for these types, right? So in this case, the compiler, when we get to the code generation for this, will look, hey, is there a user-defined assignment handler, assignment operator? Yes, there is. And we'll code generate a call to it, right? And so then the user code takes over. So then you could decide to make a special kind of, like, let's say you wanted to have a pool of strings, or you wanted to handle that differently. Like if you assign a string to something else, it actually copies that memory over too. So it allocates a new string completely, it assigns the values, it copies the actual content, so you get a new completely distinct string. So you will be able to override how that works, but the default will be very simplistic and pretty low level. And actually this I don't think, once we get procedures and scopes done, I don't think it'll be too hard to get that wired in. So, but yeah, this is not working correctly at the moment. Let's see. So yeah, implicit blocks. So this is one I gotta really think about how I want to do this. So every Basecode file is a module, and the top level of that file is module scope, which is most equivalent to like static in C. So really, Basecode does not support true globals. It does, but like when you get down to the actual ELF image, right, there are the equivalent of globals, but every module level fields are uniquely going to be name mangled. Through the import construct, you can access things from other there are common symbols in the sense that through the import, the compiler will let you access something in a different module. But at the end of the day, like if you have an A here in this module and you have an A in a different module, those are two different A's. They're not the same. If you want to access module 1A, then you have to, so no common, right? So, so that's, I don't think that level is an issue, and I think that's clear in my mind, and that's pretty much everything I've been testing with at this point, so I'm not too worried about that. Namespaces, I actually haven't gotten to, I haven't gotten to how I'm going to support externally visible symbols. So as an example, down the road, let's say you wanted to make a Basecode library and you wanted to expose a function procedure, or you wanted to expose a global variable or something. I haven't quite thought about how I'm going to do that yet. Obviously, if I do that, it has to be compatible with most other ABIs. So, I think the answer there is for Basecode itself, right? Right now, that's not, I haven't figured out what that's going to be. And I haven't figured out if there's going to be some kind of bridge or, explicit declaration thing that allows you to define something that can be used by the outside world. I don't think it's, mechanically, I don't think it's a problem. It's just more thinking about how I would really want that to work. And again, I would want to err more on the side of being explicit than not. My microphone keeps falling here. But my question is for myself, I think the answer is I want to treat these as stack frames. Yeah. Yeah, I agree. I think having some kind of, again, I haven't really thought of what that's going to look like, but having some mechanism of controlling what at the image level, right, what's being exported, what can be consumed externally, I definitely want to come up with a model around that. And then again, if there has to be some kind of conversion or some kind of buffering, proxying thing because Basecode's different than the outside world, I want to kind of contemplate whatever that might look like, and hopefully have one mechanism that kind of cleanly articulates all those parts. And it could be that by the time I get all this other stuff working, you know, a pretty obvious solution will materialize and it won't be very difficult to do that. The SAS stuff is, hello, Mr. Bandler 42. The SAS stuff was an interesting experiment in me getting sued. So now the good news is, I think the last I heard from my attorney, that issue is close to being resolved, but I learned a valuable lesson there. So yeah, that stuff's, if I do anything like that again, I'm gonna have to be, much more careful with how I go about doing it. Unfortunately, there are just a lot of parasites in the world, let's put it that way. And yeah. Yeah, it was technically patent infringement, but there were also claims of trade name and trade service mark disputes and some other things. It's bullshit, right? It's predatory. It's bullshit. It's not. There's nothing there. And I've worked for other companies in the past where that's happened to them, but I never expected my little thing to be targeted, but it was. So, lesson learned. Honestly, and again, I think the fact that I streamed it, and who knows, right? Somebody saw it, and that's all it took. If I'd have gone off and just built something and launched it, maybe they still would have come after it. I don't know. But it might have taken a lot longer because there wasn't, I wasn't out there on a channel like going into all the details. The only way you can know is to go do a patent search, which is enormously expensive and time consuming. And even then, there's no guarantees. And again, here's the thing, right? With a lot of this stuff, a lot of things in the legal system, period, you can look at a lot of these things on their face and you can say, this is not going to succeed in court, right? But it's enormously expensive. I mean, prohibitively expensive to even contemplate doing that, unless you do everything yourself, which even then that's highly risky, because if you're an amateur lawyer, you're probably going to miss something. But if you pay counsel, it's really expensive. And they know that, right? So a lot of these people it's kind of the same thing as, okay, if you get a traffic ticket, right? A lot of traffic tickets can be voided in court on their face. And there's a whole bunch of reasons why, especially, anything that's related to an automated camera. Like all those tickets can be voided on their face, but it's time investment. It's, do your research, you have to file your motions if you're doing it yourself, or you have to pay an attorney to do it for you. If you have an attorney and you're paying them, they have to appear for you. That's expensive, right? So for a ticket that might be $50 or $100, you could fight it. And again, like I said, my personal, just based on my experience of doing this in the past, I mean, it's my belief that 98% of those kinds of fines you can get out of, right? But you're going to pay a massive amount of money, or you're going to spend a lot of your own time, which is also money, to defend it. So, and this is the thing, right? This is why I call them parasites. They know this. Cities, municipalities that issue these tickets know this. They know that on a lot of these, there's, shaky legal ground, but they also know that you're not going to fight it. So the update is it's ongoing. I mean, I unfortunately, I'm never going to be able to tell you guys really any details on it, because I can't, right? I can't get into who's involved, and there's confidentiality stuff going on there that I can't breach. What I can tell you is that lawyers have been fighting with each other for months, and it looks like, that it's going to come to an end soon enough. But yeah, it's just wasted money, wasted time. So be careful. That's all I can say, is be careful. And, what you say, who you say it to, how you advertise things. Look, for the longest time, this was a long time ago now, but in the 80s and the 90s, the games industry was very tight-lipped, right? They would not, if you worked on a project, you didn't talk about it, right? It wasn't, you didn't show anybody, maybe your family got to see some of what you were working on. That was about it. And your coworkers, no one else. Very, very strict. And, to some extent, I would say the industry still is that way, although it's changed a little bit, right? For some projects, there's more disclosure than there used to be early on. It used to be that you just did not know what anybody was working on. And in hindsight, I think I understand why, right? Because if they had started talking about what they were doing, it was a tight-knit community. There were a handful of companies really that were competing, and some of them were more powerful than others. And it would not have taken much, right, for some of the bigger players to try to quash. Oh, you're making that kind of football game? Oh yeah, you're copying us. We're going to sue you, right? And so when I say be careful, I think it's just, and it sucks. I mean, it sucks that it has to be this way. But if you are going to try to make money with something, then you are probably better off not discussing the details of it until you are right next to releasing, or you have released, and then you're hyping the product, right? If it's open source, I don't think it matters. That's different. Like this compiler, nobody cares about this because I've never really intimated that there's any money, here on this, and there isn't. Like no one's ever going to pay for this. So if you're doing open source stuff, I think it's a very different scenario. But yeah, if you're doing commercial things, when I say be careful, I just mean be careful. Don't talk about it too much. I'm not saying you can't get shut down with open source. I'm just saying that the motivations there are probably a little different. I mean, again, like I say, it sucks, but 'tis what it is. All right, so I gotta go here. I'm gonna come back. So I need to take my daughter to an event at school. I'll be gone for about an hour or so, and then I will be back online, and we will start working on some of these, compiler backend code generation things. So let's see. I'm going to say hour and a half. I'm not exactly sure how long I'll be gone, but I will be back online. And then, I'll be back online for 2 or 3 hours. So, or however long I can go before I decide I don't want to do it anymore for the day. So anyway, I'll be back. I'll see everybody soon. Bye.